Hello friends, very good morning. Myself Dr. MH Annaiah. In this video, we are going to study the section of a square prism. And this square prism is being cut by a section plane which is normal to VP and inclined to HP such that the true shape of the section is going to be a rhombus of the given side. That side is given as true shape is a rhombus of size 40 mm by 60 mm. Friends, first of all, you have to place the object correctly on HP such that when it is cut by a section plane, the true shape of the section we get is going to be a rhombus. Friends, if you hold this with one of the side perpendicular to VP, what happens? You are going to get in the true shape a rectangle, and here to get a rhombus you have to place the prism on HP such that two of its adjacent sides or all the four shatter edges of the solid are equally inclined to VP. Now here friends, you can just observe, and this is a very good question, wherein the size of this square prism is not given. They have given only the height. But how to construct the top view of this? Then only you can have the construction of the front view. So what is to be done friends now? It is being cut by a section plane bisecting the axis. That is to say, it is going to have all the four vertical edges of the solids cut by the section plane. And here you are going to have, let me just mark these points as A dash. This is B dash, D dash. This is last one is C dash. This is C1 dash, B1 dash, D1 dash, and this is A1 dash. Friends, here are to mark it as AA1, BB1, CC1, DD1. Friends, now I have marked this, but where is the dimensions of the square? That's not given. But remember, friends, whenever any of the prisms, whether a square or a rectangle or a hexagonal, pentagonal, or a cylinder, which have got the uniform cross section throughout their height, are cut by any section plane between the top edge or top surface and the bottom surface. It could be cut by a horizontal section plane or a section plane passing like this, a section plane passing like this, or some section plane passing like this. The whole top view of the solid gets hatched. That is to say, we are going to get the sectional top view as a figure similar to the base of that. Here friends, in the true shape, it has to have a dimension of how much? 40 by 60. 40 by 60. So this dimension, maximum dimension here is this dB. There's a diagonal. So once you know this diagonal as 40 millimeter, there is vertical diagonal. Both will have the same dimension. Because this dimension is perpendicular to VP or parallel to VP, you can see this in its true shape. And hence, for this problem, whenever the cylinder is cut by the section plane inclined to HP and normal to VP, this dimension is going to be the shorter side or shorter diagonal of the rhombus. So friends, we are going to construct the square taking the length of the diagonal as 40 millimeter. 40, this is 40. You can construct a rectangle, sorry, square, and project all these points to obtain the front view of the solid. So this concept is very important because without knowing that whenever the rhombus is there, it will have a dimension. Say 40 into 60 will have 40 is the diagonal of that square. So friends, now we are going to draw a section plane passing through the midpoint of the axis such that this dimension or the length of this section plane here should have a dimension of 60. So what do we do? I take the center and radius is equal to 30 millimeter. I draw an arc on both the sides of this and I join these two points by a section plane, and I call this section plane as S and S. This section plane is perpendicular to VP and is at the midpoint of the axis. Friends, now after the solid is being cut by the section plane, the portion that is left over once you throw out the upper piece is this part. And this part I am going to show by visible lines. The base of the solid is not cut by the section plane. Friend, this is the part P for which we are going to draw what is called the sectional top view and front view. Friends, what are the questions being asked? Draw the front view. Friends, this figure will represent front view of the solid. Then, since it is cutting like this, friends, the whole of the top view gets sectioned. So I will show all these lines, all these, by lines drawn at 45 degrees to the horizontal, and that is how it is going to appear. Friends, this will give you the sectional top view of the solid, which you call it as STV, and we need to have sectional side view for this. How to obtain the sectional side view, friend? For the cylinders, square pyramids, and square prisms, whatever the front view you have got, the side view will be just a photocopy of that. So friends, I am going to construct here the left hand view or left side view of the figure having height is equal to 80 and this width will be the same as this. So let us say this is how it appears. So let us assume that it is not cut by any section plane and then transfer all these points by having a line drawn at 45 degrees here. We can obtain all these. So friends, this line represents D double dash, D1 double dash. Next is A double dash, C double dash. Last is B double dash. Bottom line, you are going to have B1 double dash, A1 double dash, C1 double dash. This is D1 double dash. Yeah, D1 double dash. O dash you have got here, and this is O1 double dash. O double dash and O1 double dash. Friends, now as you see in the front view, all the four vertical edges, namely AA, BB, CC, and DD, are cut by this section plane. Now, let us name all these as 1, 2, 3, 4. Suppose on AA it is cut at 1, I will mark 1 here. BB, I will mark it as 0.2. CC 3 and point DD is 4. So this point on DD is 2 and 4 and this is 0.3. We have got all these. Now friends, you transfer all these points from the front view to the right end view to obtain the sectional side view or sectional end view. Friends, let me start from this point 1. 1 is on AA. So I am going to write a horizontal line till it touches this AA. So this is point number 1. Next, 2, 2 is on BB, exactly in the center. 2, 2 is on BB. So this is point. Then 3, 3 is on CC. A horizontal line here. This is going to be point 3. And finally, on DD you have point 4. So 2 and 4 will be on the same line. So this is point 4. And for the prisms and pyramids, the points so obtained are to be joined by dark lines or visible lines. This is one edge, second, third, and this is the fourth edge. Again, friends, this 1, 2, 3, 4, whatever the figure you have got, is to be hatched or sectioned by drawing lines at 45 degrees to the horizontal. Friends, you can see here on this edge AA, 1 to A1 is retained. So I am going to show that by a dark visible line. Similarly, on BB and DD, you have the portion retained and 2 to 1 BB. And the bottom portion of the solid is intact. And friends, the portion above this, now this line, this and these lines are to be shown by very thin lines. So friends, this will give you sectional end view or sectional side view or left sectional end view, because this is obtained on the right profile plane. Friends, you got the front view, you got the sectional top view, you got the sectional side view. He is asking us to draw the true shape and also to obtain the side of the prism. Friends, this is the side. After you construct this square taking 40 millimeter side, the dimension of this can be measured. You can know what should be the side of the prism. That can be obtained by using a scale. Then you want, friends, the inclination of the section plane with HP. Friends, you know this distance we have taken as 30 and this is taken as 30, and this angle with the horizontal will give you what is theta, the angle made by the line with the HP or with the XY. That can be measured. Finally, friends, we need to draw the true shape of the section. Friends, to obtain the true shape of the section, we have to draw a line parallel to the section plane at any convenient distance to the left, because we have to hold a mirror parallel to that to obtain the true shape. So friends, I am going to draw a line parallel to this at any convenient distance. That is to say, this line is parallel to the section plane. And from these points 1, 2, 3 and 4, I am going to draw perpendiculars to that. So this is one line, and you have this as a second line. In between, you are going to have the third line. So these are all equally spaced. So friends, I have drawn this line parallel to XY or the section plane SS, and from here I have drawn all this line perpendicular to that through this point. Friends, on this line we have to get point 1. Take the distance of 1 from XY and mark it here. This is going to be point 1. Similarly, on the other end, you got 3. 3 and 1. 1 and 3 are at equal distance. So you can have this as point 3. And you should get 2 and 4 on this. On this line, you should get 2 and 4. 2 is at a farther distance, 4 is nearer to that. So we can have this as point number 4, and 4 to 2 distance you take and mark somewhere here. So friends, if you join all these 1, 2, 3, 4, this figure will give you the true shape of the section. And friends, this true shape of the section has to be hatched by drawing lines at 45 degrees to the horizontal. And if you observe this, friends, the distance between 1 and 3, this is 1 and that is 3, that is very obviously equal to the length of this section plane which is cutting these edges. And friends, distance from 2 to 4 or 4 to 2 is equal to 40. So this dimension is going to be 40. Alright, Also here friends, this dimension is going to be 40, and as a check you can verify that this dimension 2 to 4 is 40, then only you are going to have a figure like this. Friends, this is the figure you get is called the true shape, and it is a rhombus. Sometimes they will give you the angle made by the section plane. They give the side and ask you to draw the true shape and name the true shape. Very obviously, the true shape is a rhombus, and it has got the minor axis 40, major axis is this one. This is 60. So this is going to be 60 from here to here. Friends, I hope and I am very sure that all of you would have followed the procedure to draw the section of a square prism when it is cut by a section plane inclined to horizontal or HP and normal to VP so as to obtain the true shape of the section as a rhombus with minor axis 40 and major axis measuring 60 millimeter. Friends, this is one of the beautiful question on this particular square prism. Please go through it completely, and after going through the complete video, if you find or if you feel that this video is of some advantage or benefit to the student community, please share this information about the video and my YouTube channel link with all your friends. Have a wonderful day. Thank you for watching my video.